Good day, welcome to One-on-One Maths Private Tutors. We continue with this topic in sequences or number patterns for O-level Cambridge. Today we are going to look at the nth term of quadratic, cubic, and exponential sequences. We are using the position of the term to find the value using quadratic, where the highest power of the position is 2. Since in quadratics, the highest power is 2. Cubic, we are using the highest power being 3. And exponential sequences, we are taking the position as a power. We'll be using the position as a power. Okay, so let's look at how this takes place. So we have this sequence here. Remember, we must have a position to make things easier for us. Position, which is our n, and our value or term n. Okay, our term. So on position 1, we have 1. On position 2, we have 4. On position 3, we have 9. On position 4, we have 16. On position 5, we have 25. Now, in this sequence, there is no term-to-term relationship because there is no one value you can add from this term to that term and also from this term to that term. But what we can see here is these numbers are perfect squares. On position 5, we have 25. So we can see these numbers are perfect squares. This number is 1 squared. 1 is 1 squared. 4 is 2 squared. 9 is 3 squared. 16 is 4 squared. 25 is 5 squared. So directly taking from the position, we can see that this is the square of the position. For any position, even if we go up to position 100, this will be 100 squared for the term. So the formula for the nth term of this quadratic sequence, Tn, is equal to n squared. What are we saying? We're taking the position and squaring it to get the term. Okay, if we square 1, we get 1. If we square 2, we get 4. If we square 3, we get 9, and so forth. For this sequence here, we are given position n and our term Tn. At position 1, we have 1. At position 2, we have 8. At position 3, we have 27. At position 4, we have 64. At position 5, we have 125. Now, we can see that these are perfect cubes. 1 cubed is 1, 2 cubed is 8, 3 cubed is 27, 4 cubed is 64, 5 cubed is 125. So for our nth term, any term in the sequence, if we want the 100th term, it will be 100 cubed. Another sequence we will look at is the exponential sequence. Let's look at this sequence here. Our position and our term Tn. We have 243. These numbers are powers or exponents of 3. If we say 3 to the power 1, we get 3. 3 to the power 2. The position is 2, so the position is the power. We get 9. If we say 3 to the power 3, we get 27. 3 to the power 4, we get 81. 3 to the power 5, we get 243. So the terms are exponents or powers of 3, starting from 1 going up. So if we want a term at any position, say position 53, to get the term at that position, we would say 3 to the power 53. Now our formula for the nth term If we want t at any position n, it will be equal to 3 to the power n. That will be our formula. Let's look at this question. Find the formula for the nth term of this cubic sequence. So let's look at position n and our term Tn, term n. Then we have on position 1, we have -1. On position 2, we have 6. On position 3, we have 25. On position 4, we have 62. On position 5, we have 123. So the question says, find the formula for the nth term of this cubic sequence. Since we are told it's cubic, the position cubed has to play a role. We would want to find the cubes of our position because we have to use the position and cube it. Position and cube it. So we would want n cubed, which is 1 cubed, 2 cubed, 3 cubed, 4 cubed, 5 cubed. 1 cubed will give 1. 2 cubed is 8. 3 cubed is 27. 4 cubed is 64. 5 cubed is 125. Okay, so let's see the difference between these cubes and our terms. 1 minus -1 is 2. 8 minus 6 is 2. 27 minus 25 is 2. 64 minus 62 is 2. 125 minus 123 is equal to 2. So we can say n cubed minus Tn will give us 2. These are the n cubed values. If we subtract the Tn values, we always get 2. So the formula for the nth term, we take this Tn to that side and the 2 to that side. N cubed minus 2 is equal to Tn. We can express it as Tn is equal to n cubed minus 2. So that is how we get our formula for the cubic sequence. Let's look at another question. Find the formula for the nth term of this quadratic sequence. We are told it's quadratic, so we have our position and our term. Our position is n, our term is Tn. In position 1, we have 8. On position 2, we have 13. On position 3, we have 20. On position 4, we have 29. On position 5, we have 40. And we are told it's a quadratic sequence. Okay, so quadratic means we are squaring the position. 1 squared, 2 squared, 3 squared, 4 squared, 5 squared. Okay, so this is our n squared here on the table. So what will we get? 1 squared is 1. 2 squared is 4. 3 squared is 9. 4 squared is 16. 5 squared is 25. Now let's look at the difference between the position squared and our terms. 8 minus 1 will give us 7. 13 minus 4 will give us 9. 20 minus 9 will give us 11. 29 minus 16 will give us 13. And 40 minus 25 will give us 15. Now this is another sequence. On position 1, we have 7. On position 2, we have 9. On position 3, we have 11. On position 4, we have 13. On position 5, we have 15. So we have another sequence now, which is position and term. On position 1, we have 7. Position 2, we have 9. On position 3, we have 11. On position 4, we have 13. On position 5, we have 15. Let's Now look at the difference between successive terms. 9 minus 7 is 2. 11 minus 7 is 2. 13 minus 11 is 2. 15 minus 13 is 2. So this is a linear sequence with a common difference of 2. So we should have 2n in the nth term formula. Now 2n, we have 1. 1 times 2 is 2. 2 times 2 is 4. 3 times 2 is 6. 4 times 2 is 8. 5 times 2 is 10. So we have 2n there. Now let's look at the difference between the terms and 2n. 7 minus 2, 5. 9 minus 4, 5. 11 minus 6, 5. 13 minus 8, 5. 15 minus 10, 5. So we can say 2n, which is this one, plus 5 will give us the term. Okay? So 2n plus 5 is Tn for this linear sequence. 2n plus 5 will give us 7. 2 plus 5 will give us 7. So 2n plus 5 is the formula for this. Okay, let's look here. 2n is 4 plus 5 will give us 9. 2n for position 3 is 6 plus 5 will give us 11 and so forth. All right. So now to combine it, here we have n squared and 2n plus 5. So the term at any position n will be n squared plus 2n plus 5. But let's move on. The nth term of a sequence is found using the formula un is equal to an squared plus bn. Okay? u1 is equal to 3 and u2 is equal to 8. Okay, so we have said un can be used in place of tn. So we are just saying n, our position, and our term, tn. So on position 1, we have been told tn or our un. On position 1, u1 is equal to 3, so we have 3 there. On position 2, u2 is equal to 8. Term 2 or u2 is equal to 8. So we are asked find u3. For position 1, n is 1 and the term un is 3. So we can say 3 is equal to, substituting it in this formula, 3 is equal to a times 1 squared, since value of n is 1, plus b to the power 1. Then we have 3 is equal to a plus b. For position 2, n is 2 and un is 8. So we can say 8 is equal to a 2 squared plus b to the power 2. Simplifying this, we have 8 is equal to 4a plus b squared. For the first term, we have equation 1. For the second term, we have equation 2. So we solve these two equations simultaneously in order to obtain a and b. I'm using elimination, so I can say 1 times 4, which will give us 12 is equal to 4a plus 4b. We have equation 3. We can go on to say equation 3 minus equation 2. So this minus that. 12 minus 8, 4 is equal to 4a minus 4a, 0. We have eliminated a, and 4b minus b squared. We can take everything to the left. B squared minus 4b plus 4 is equal to 0. Let's solve this quadratic. Then we have b squared minus 2b minus 2b plus 4 is equal to 0. Then we have b bracket b minus 2 minus 2b minus 2 is equal to 0. So we have b minus 2, b minus 2 is equal to 0. Then we have b is equal to 2. When b is equal to 2, we would want to find a. Substitute b in 1. We have 3 is equal to a plus 2. We have a is equal to 1. So our equation now becomes, this equation now becomes un is equal to n squared plus b is 2 to the n. To find u3, n is 3, 3 squared plus 2 to the 3, which will give us 9 plus 8, which will give us 17. So at position 3, we have 17. We've just found U3. Thank you.